Okay, we are looking at the first FRQ on the review, and it says gravel is being excavated from a pit at a rate of 12 meters cubed per minute, so that's going to be important. It is being placed in a conical pile, so that tells us the shape, and the height of the pile is always 1/3 of its base diameter. So remember, in these problems, we can use Kafka if you want to. That is not something that you have to use. It's just a tool to help you out if you're stuck. And you don't even have to label the things if you just want to write them down, okay? But before we even start, let's see what we know from this first part of the problem. Excuse me. The first thing that they give us is a rate. So let's see what kind of rate that is. So that means it's going to be a derivative. And this is going to be meters cubed. Oops, let's leave some room for the number. 12 meters cubed per minute. So we need to figure out, what is this the derivative of? We know it's a derivative because it's a rate. Well, there's two things. One, they say gravel being excavated from a pit. So that means like the entirety of it is changing. This is also a cubed. Since it's a cubed and it's talking about everything that's on the inside, that's the derivative of our volume. That is the rate of our volume, okay? It's being placed in a conical pile, so that means a cone. And the height of this pile is always 1/3 of its base diameter. So it's giving us a proportion here. What it's saying is that the height means equal to 1/3 of its diameter. What you want to be careful here is this talks about diameter. In all of our problems, we use radius, and that's what's going to be in our formula. So diameter is really 2 times the radius is how we can change that. So really, if we want to get height and radius in the same equation, 2 is over 1, so we multiply those together and we get 2/3. 3, sorry, my stylus isn't working, radius. So that's our proportion. So we have three things. We have dv dt, we have the shape, and we have a proportion for our height and radius, okay? So the first thing says, if neither height nor radius are constant, aka we cannot plug them in before we take the derivative, okay? Write a differential equation, dv dt, that relates r, h, dr dt, and dh dt, okay? Well, all this means a differential equation, writing a differential equation, that means you're just taking the derivative. That's basically what that's asking us. So we have to use our original volume. We have to take our original equation. So for part A, we're going to use the formula for the volume of a cone. This is something that you will be given. It's not typed on the review, but it is in your notes, and it was on the board if you wrote that down. It's 1/3 pi r squared h is our volume formula. So they're asking for a differential equation. So it's just going to have all these parts. It has r, it has h, it's going to have dr dt and dh dt. And it's going to be called dv dt because we're taking the derivative of volume. So when we do this, we have dv dt, that's the derivative of the v. And then 1/3 and pi, those are just numbers, so I'm going to leave them out front. I'm not going to worry about them right now. I can distribute them later if I want, or I can just leave it outside and get rid of them that way or whatever. So then I have the product rule because I do have r squared times h. If you would like to, you can substitute in h and get only r's. So for h, you would put 2/3 r right here and then take the derivative. That is also fine. There are multiple correct answers to this part, so it's just however you decided to solve this problem. If you use the product rule, it's the first. So first is r squared times the derivative of the second. So the derivative of the second is dh dt plus the second, so I write h this time, times the derivative of the first. So we have 2r. We took the derivative of r, so dr dt. And you can stop there. Remember, this is an FRQ. Nothing has to be simplified. We have dv dt, so really, we're done. That's part A. Or whatever you decided. If you want to look, if you plugged in R or H, and you want to ask about the correct answer for that, you can in class. So part B. Let's choose a different color. Let's see what part B says. How fast is the radius changing at the moment when the height of the pile is 6 meters? Answer in centimeters per minute. Okay, so there's a couple things here. How fast is the radius changing? How fast means a derivative. They tell us it's radius, so we're looking for dr dt. At the moment when the height of the pile is 6. So they're literally telling us h is 6 meters. Be careful here. They want their answer in centimeters. So after we do all our work to get from meters to centimeters, there's 100 centimeters in meters. So we have to multiply our answer by 100. And then we can write it in centimeters. So be careful of those things. So this is what we're looking for. This is additional information that they gave us, and then we're going to have to change our units at the end. So we're going to be using the derivative that we just found. So we have dv dt equals 1/3 pi times r squared dh dt plus, I'm just going to rewrite the order of that, 2rh dr dt. So let's see what we can plug in. Well, we want to find dr dt. So dr dt needs to be the only thing that I don't plug in. dv dt, they gave us way back at the beginning. They told us in the original problem that dv dt was 12. 1/3 is a number, pi is a number. We need our radius. Well, they only gave us height here, and they didn't give us that radius before. So we don't have that yet, but we are going to find it. dh dt we also don't have. R, again, we don't have. Height, they did give us. They told us height was 6. So those 3 missing ones, here, here, and here. All of those are going to come from that proportion that we used. So they told us we found h equals 2/3 r. So there are 2 things. We need the regular radius and we need dh dt from this. So we can do 2 things with this. First, we can plug in h, so we get 6 equals 2/3 r. Multiply both sides by 3, we get 18 equals 2r. Divide by 2, so r is 9. So we get these 2, 9 here, 9 here. We still need dh dt. Well, there's a second thing that we can do with this equation. We can take the derivative of it. Just like we can take the derivative of volume, we can take the derivative of h. So the derivative of h is dh dt equals, the derivative of 2/3 r is just 2/3 dr dt. So dr dt is what we want to find. So we can just take this, and instead of dh dt right here, we can write 2/3 dr dt. Which is okay because we're solving for dr dt. So it's okay to have dr dt in the problem. It's not okay to have dh dt in the problem because we don't have anything for that. We can't solve for 2 things at once. So let's plug all this in and see if we can get our answer. So we have 12 equals 1/3 pi 9 squared times 2/3 dr dt plus 2 times 9 times 6 dr dt. So all we have to do is simplify. Yes, we plugged all our numbers in, but we don't have dr dt equals. As soon as we have dr dt equals, we don't have to do anything else. This is an FRQ. We don't need to simplify or anything. Okay, so what I'm going to do first, we have this big thing in the parentheses, but I'm going to move this first. We can multiply both sides by 3 to get rid of that 1/3, and divide both sides by pi to get rid of pi in the front. So we have 3 times 12, we have 36 over pi times 9 squared, or equals 81 times 2/3 dr dt plus 2 times 9 is 18 times 6 is 108 dr dt. So then we just have this 2/3, so we have 81 divided by 3, we'll get 27, times 2, we get 54 dr dt, plus 108 dr dt. All of this is equal to 36 over pi. And then, since this is 54 dr dt plus 108 dr dt. So imagine if this was 54x plus 108x, we just add those numbers. Well, same thing here. Dr dt is just dr dt. So we can add those together. If we add 54 and 108, we get 162 dr dt. Over here, we still have 36 over pi. So we just need to divide both sides by 162. So this 162 is just going to join pi, dividing 36. So there's dr dt. Let's double check, make sure we've done everything we need to do. Dr dt, we plugged in h. Oh, the last thing. Be careful here. Our units. Right now we're in meters, so we need to multiply our answer by 100. So when we do that, it just gets multiplied to the top, so we have 3600 over 162 pi, and we've changed to centimeters per minute. They actually told us what our unit should be. So that's our answer to part B. Okay, so for part C is very similar. There's a couple different ways you can solve part C. So let's go up and read the problem. How fast is the height changing? So now they're asking us for dH dt. At the moment when the height of the pile is 6, so that's the same as before, so we can use our information from before. And then again, answer in centimeters per minute. So, part C, we're still using that dV dt that we found very back in the beginning. So dV dt was 1/3 pi times r squared dH dt plus 2hr dr dt, or RH. It doesn't matter the order, it's all the same thing. So we can solve it just like we did part B, finding all of these numbers to plug in. dV dt was 12, 1/3 and pi are numbers, r was 9, dH dt we don't know, that's what we're trying to find out. We don't want to plug that one in. H is 6, r is 9. dr dt So if dH dt was 2/3 dr dt, then 3/2 of dH dt is dr dt. So we can use that. 3/2 dH dt. So 3/2 dH dt. If you wanted to, we did just find dr dt right here. Okay, so this was after centimeters, but remember all of these things are in meters. So you can't use your centimeter answer from part B. You could use your meter answer. I don't want to plug in a fraction like that because I know it might mess up some of my simplifying when I have to move things over, but you could absolutely do that. You would still get the same answer, okay? So remember, there are multiple ways to solve these problems. There's not one right way. As long as you're following all the rules, you're good. So if we do it this way, we have 12 equals 1/3 pi r squared, so 9 squared is 81, dH dt, plus we have 2 times 6, which is 12, times 9, times 3/2, dH dt. So let's simplify that. We can do 12, let's see, 12 divided by 2, we'll have 6. So we really just have 6 times 9 times 3, which is 162 dH dt, plus we have 81 dH dt. And then I would move this again, so multiplying both sides by 3 gets rid of the 1/3, dividing both sides by pi. Again, I get 36 over pi equals all of this. So I can add those two together. 81 plus 162 is 43 dH dt equals, we have 36 over pi, so we want to divide both sides by 243. So 243 just gets added on the bottom, or it joins, that's what I mean, the pi on the bottom, so 243 pi is our new denominator, all over 36 equals dH dt. And then, remember this is meters, so we have to multiply by 100 to get our centimeter answer. So again, it's 3,600 over 243 pi d centimeters. Sorry, don't know why I wrote that. Centimeters. Come on. Centimeters per minute. I do want to show you one shortcut for part C. So remember how we have this equation right here. We have an equation for dH dt. dH dt is 2/3 dr dt. So here's our shortcut. dH dt is 2/3 dr dt. Well, guess what? Right here, we found dr dt. So you actually don't have to go back to the volume formula. We don't always have this, but when we do, it's really nice because we can just plug this in, dH dt, and in this case, we can use the centimeters answer because this has nothing to do with centimeters. The 2/3 is just a proportion. It's not a measurement, okay? So we're not already using this height and dV dt, things that are already meters. So we can go ahead and use our centimeters answer. And we have 2/3 times 3,600 over 162 pi. Okay. If you do simplify that, you can get the exact same answer as before. 3,600 over 243 pi. This is already centimeters per minute, which was our answer before. These two are the same thing. So there is a shortcut if you can see that, but the long way works. Okay, you already did that process once for the previous part, so it's really up to you if you can recognize that or not. Either way is a correct answer, so don't worry about it. Okay, so that's it for this problem.